80% of the buildings in use today will still be in use in 2050. Even if we wanted to and could afford to, and it was the right thing to do from a carbon perspective, we cannot build ourselves out of the challenges we face today. We need to look after the assets we already have well, recognising that nothing stands still and change is pretty much the only constant about which we can be certain. We need to future-proof the assets we have today for tomorrow. This sounds like a massive task, and it is. The scale and likely expense of attempting this significant task puts many people off. I hear people say, "We know it's a good thing to aspire to, but it's too big and too difficult, so let's stick to what we're doing now and hope that everything resolves itself." That's a strategy of hope, and not one that I would recommend. As retired US General Gordon Sullivan says in his excellent book, hope is not a method. We know that every journey begins with a first step, and helpfully even big tasks are made up of a number of smaller tasks, which we can take forward one at a time. But to do this well, we need to be mindful that the small tasks are often interlinked. We will save time and money later if we understand the direction of travel before we start on the smaller tasks, so that as each is completed, they contribute step by step to the bigger picture. I'm Steven Boyd, and I'm delighted to be giving this keynote address in this year's SFG20 Virtual Summit. I have titled this keynote, Getting Started on Your Journey to the Future. I've been privileged to hold senior roles in the British Army and the Civil Service, including as the Army's head of its large estate and as the Chief Executive of the Government Property Agency, responsible for the Government's office estate. Using my experience and lessons learned over the last 2 or even 3 decades, I will try to get under the bonnet of where to start on the journey to the future, touching on the issues addressed in the summit's panel sessions, but perhaps some others too. There is always a risk in predicting the future. I have no crystal ball, and I'm certainly no Nostradamus. That said, it's easy to be captured by what we don't know. Not knowing can be a reason, and sometimes an excuse, not to act. I've always been an advocate of focusing on what we do know. That's a much better basis for action. So what do we know that will affect the future of asset management? My starter for 10 might include data and digital tools will be used increasingly, and managing data will become at least as important as managing the physical asset itself. Our climate is changing. It will get hotter, and climate events such as heavy rain will become more frequent and more extreme. The need to reduce carbon emissions will become increasingly more important and urgent, and is likely to be enforced by ever stricter legislation. Even this basic analysis can lead us to deduce that in order to future-proof the built environment, we should take actions to start gathering the right data, employ good digital tools, be open to new technologies such as digital twins and AI, make our buildings more resilient to climate change, reduce carbon emissions, and perhaps most challenging, grow the skills to do all of the above. In this keynote, in thinking about a journey towards future-proofing assets, I'll come back to each of these deductions with a focus on where do we start and what can we do today. Firstly, I will explore the direction of travel for our journey, then say something about the data needed to help us along the route. I will then explore how digital tools can help us deliver. Next, I will also cover some ideas on responding to the climate challenge, and finally, I will reflect on how we might grow the skills we need for this journey. I do think that small actions taken early can make a big difference. But before you stop listening to this talk and rush out to take the first steps on the journey to the future, it's worth reflecting on the direction you want to travel in. Deciding on a direction of travel for years into the future seems like a hard question. Perhaps it is. But fortunately, we don't need to be too precise. I find a helpful analogy to stick with the concept of a journey. Consider a journey from the south of the UK to Scotland. Deciding that we plan to undertake this journey is an important first step. Recognising that it may take some time and that we may need to stop along the way is a second. Using this analogy, I would suggest that we can be relaxed for now about where exactly our eventual destination in Scotland is. It may be Edinburgh or Glasgow, but that's not so important for now. What is important today is where are we starting from? Is it Bristol or London? To set out our direction of travel in future-proofing our buildings, we need to know 2 things. Firstly, Where approximately are we heading, with an understanding of what good looks like so we know when we are approaching our destination? And secondly, where are we starting from? How would we honestly describe the performance of our assets today? What good looks like in the future is likely to be similar for all asset owners, but will not be exactly the same, as each will have their own priorities. I strongly recommend that you define what good looks like not in building terms, but rather in the outcomes to be achieved. It can be tempting to describe the end state using measures such as condition and energy use. These are necessary stepping stones, but are not the end state that we should be focused on. It's much better to focus on desired outcomes. Outcomes might include that our assets are, at least, compliant with legislation and cost effective, and most likely also popular with the people who use them, low in carbon emissions, and resilient to climate change. Having defined, perhaps rather loosely, the outcomes we want to achieve at the end of our journey, we can turn our attention to where we are now. Understanding how close we are to our desired outcomes today will inform the early steps on our journey. Some will already be able to describe asset performance very well. Most will struggle. Few will have all the necessary data to evidence the start point. It's likely that we can conclude, even at this early stage, that we are going to need some good data. Probably more than we have now, but not data for data's sake. There are plenty of suppliers who are keen to persuade you to begin the significant task of gathering data on everything. This isn't needed. Only the minimum necessary data to judge progress towards the desired outcomes is required. Measuring other data points is not only wasteful, but it's also potentially confusing. It risks losing sight of the small number of necessary data points that we actually need in a large crowd of other data points that are interesting, but not necessarily helpful. Margins in building maintenance are often too low. Squeeze costs further in an already stretched construct is not likely to be helpful. The maintenance balloon is pretty difficult to squeeze further, and even if it were possible to do so, it's very likely that it will bulge out elsewhere in an inconvenient way. For example, in poor experience of building users, perhaps because of drab and creaking condition, or in disruptions that distract them from their daily work, or perhaps even both. Albert Einstein is reported to have said that insanity is doing the same thing over and over and expecting different results. If we want different and better outcomes, we need to take a different approach. Fortunately, the use of data and digital tools presents several opportunities to step towards desired outcomes, including user experience and cost efficiency. Here are 4 examples of how maintenance can be informed by data, in increasing order of complexity. First, experience-based maintenance, second, use-based, then condition-based, and last in this short list, predictive maintenance. Experience-based maintenance is a good place to start on a journey towards using data to best effect. The most effective operations teams are likely to be those that focus on the things that have the biggest effect on user experience. Things like comfort, temperature, and lift reliability. Lots of data is no doubt available on many aspects of asset performance, but if half a dozen things have the biggest impact on user experience, start by only measuring those. Secondly, use-based maintenance. Gathering usage data can reduce the amount of wasted effort expended in doing things that are done simply because they've been timetabled to be done at that point. Why replace a filter at the fixed time defined by a manufacturer when the equipment of which it forms part has hardly been used in that period? A risk-based approach on the actual rather than assumed use can considerably reduce the frequency of maintenance in some asset types. Condition-based maintenance uses sensors to monitor the condition of a small number of high-value components to plan maintenance interventions at the right time. For example, planning interventions for motors or compressors based on sensor-reported condition. And finally, data trends can help us to move towards predictive maintenance, an advanced approach to maintenance in which trends are analysed to predict when equipment needs to be maintained or replaced. These 4 examples demonstrate that digital-led maintenance is not one thing, but a range of approaches using data to improve outcomes. Some approaches are quite straightforward and a great place to start. Others can add value too, but are likely to be adopted at a much later stage in our journey. You will have noticed that digital-led maintenance, like many of the decisions required in our buildings, needs data. I hear from many that the task of collecting data, including accessing data held in legacy and proprietary systems, is prohibitive. It's true that there is an investment required here, but I would argue that it's not necessarily significant provided that you don't try to gather all data on everything at the same time. A minimum viable data set is the smallest amount of data required to make an effective decision. An MVD can be used as a starting point for data sharing and collaboration, and importantly, can be expanded and refined over time. The desired outcomes you identify will shape the MVD, allowing you to focus effort on collecting this subset of data rather than chasing around trying to gather every single data point. Hopefully, some of the data necessary to populate your MVD will be readily available. Inevitably, some will be missing. That's to be expected. Identifying missing data enables collective action to be taken to fill these gaps. Actions to do this might include changing the way that feedback is gathered from building users, carrying out building surveys to gather missing data points, for instance on asset condition, or installing additional sensors such as air quality sensors or electricity smart meters. Your MVD must also be a single version of the truth. Very often, multiple datasets can be gathered in good faith to help collate the data needed. But having multiple, often very similar and different versions of the truth is actually very unhelpful. In my experience, it's always better to have a single version of the truth that everyone agrees to use, even if at the start it's neither complete nor accurate. Now turning to data standards for the built environment. Over the last 10 to 15 years, significant progress has been made in the effective use of data in design and construction. Regrettably, however, similar progress has not been made in the operational phase. This is despite the fact that an asset may take 3 or 4 years to build, but be in use for 30 years or more. Not only is this a missed opportunity for improved asset management, it's also a significant impediment to genuine whole-life approach. From concept to operations, into refurbishment, and back into operations. This is something that I've been frustrated by for at least 10 years. You know, I think this frustration is getting worse with time. This is in part due to the obvious progress in design and construction, and the continued ineffective transfer into operations of large quantities of very useful data available at practical completion. A genuine whole-life approach to asset management is key for operational efficiency. To achieve this, data standards, including SFG20's maintenance guidance, needs to be better aligned. Better alignment of the available standards, including NBS's Uniclass, RSES's NRM, and SFG20 data tables, would help everyone. I am encouraged to hear that these standards will be increasingly aligned, and this has the potential to lead to significantly improved productivity across the whole sector. Not only will this address the frustrations that I know I share with many people around the data and the momentum that is lost at practical completion, it could also have other far-reaching benefits, including making it possible to integrate cost and carbon into building models and enabling a more streamlined approach to midlife asset refurbishment. I believe that all the parties involved now see the mutual benefit of collaboration, and with luck they can agree to work together, and quite soon. The whole sector will benefit. Asset owners, facilities managers, software developers and equipment suppliers too. I started trying to develop a methodology for aligning sector data standards whilst a States Director at the HMRC. Several people told me that it was too difficult and that I shouldn't bother. I'm afraid this only made me more determined. I sponsored a series of pilots at HMRC and subsequently in the Government Property Agency, and these incrementally proved the way. By last year, after nearly a decade of steady progress, a workable methodology was pretty much there, with great progress towards 5D data for projects, incorporating cost and carbon, and significantly better digital soft landings on project completion, enabling a smoother start to facilities management. At this point, I should say that ownership is pretty important. Not only ownership of the outcomes that you're working towards, but ownership of the key data itself. Whilst it's normal for the supply chain to own the data generated in design and construction, this should not be the case in operations. Suppliers might manage data on behalf of the building owner, but the owner should not give up this very valuable digital asset. It's not inconceivable, and some might say that it's even likely, that the value of built assets in the future will be informed by the digital representation of the asset as well as the physical asset itself. Without suitable data, evidence-based decisions cannot be made to deliver on desired outcomes, perhaps including improved experience and reduced carbon emissions. So anyone buying an asset without good data is buying an asset that's intrinsically difficult to manage and a struggle to operate to realise best value. I suggest that not only is it sensible to begin to collect and analyse data needed to deliver operational outcomes, but it's also sensible to do so to secure the future value of the asset. All the more reason for the owner to own the data related to their assets. To recap on what we've covered so far in starting a journey towards the future, I've described the importance of defining a broad direction of travel by identifying and ideally prioritising some end state outcomes, the opportunities presented by digital-led maintenance, and how to begin to collect the data necessary to make the decisions needed to progress towards these outcomes. Not all data on everything, but a very keen focus on a minimum viable dataset. I've also made some points on the ownership of data and the progress being made towards more aligned data standards in the sector. All very interesting, and hopefully good advice too, but perhaps not so practical. We need a way of holding, analysing and exploiting this data. We need some appropriate digital tools. Some people listening to this talk, potentially including those that listened to the panel on this subject earlier, will immediately say that the vehicle to hold and manage data and to enable these types of digital-led maintenance is digital twins. I do not disagree that digital twins will be part of the journey, at least in some assets, but they're not necessarily part of the early steps in that journey. Digital twins can indeed be very useful, but they're not an end in themselves. They are a vehicle to enable decisions about assets to help deliver our desired outcomes. They're also quite expensive and difficult to deliver in all buildings in a complex portfolio in one giant leap. The good news is that we don't need to do this. We can and should start small, focused first on the things that make the most difference and build towards a fuller digital representation one step at a time. Before I look at how the available digital tools can be used effectively, let's not dismiss digital twins too quickly. They're a great aspiration, and it's worth briefly thinking about what we mean by a digital twin. It sounds great, but what is it? My own interpretation, which is not necessarily correct from an academic standpoint, is that a digital twin is made up of two elements, a physical twin and a performance twin. In the case of a building, the physical twin is a model of the building and its systems. It can be a 2D drawing or a complex 3D BIM model. Each of these is valid, and most large asset portfolios will have both of these types of physical model. The physical model describes the size, shape, function and condition of the building systems and its key components. This physical element of the digital twin contains largely static data. It does need to be kept up to date, but changes are likely to be infrequent. The performance twin, on the other hand, contains dynamic data that's always changing. Data points may include temperature, air quality and occupancy. This is quite a different data set, but of course it doesn't make sense without the physical model. Where in the building is it too hot and where is the air quality too low? A fully swept up digital twin needs both physical and performance elements. As the latter depends on the former, it makes sense to start with improving our understanding of an asset's physical twin, and in parallel also beginning to gather the key performance data needed to inform progress towards our desired outcomes. I'm sure that we can all agree that digital twins may well have a place in our future plans. Being mindful of the possibility of a full digital twin solution at some future point, and working towards that, is part of future-proofing our assets. For now at least, many people will use other tools. Today, most asset owners and operations teams already use digital tools extensively. Computer-aided FM or CAFM tools are common, but of varying capability. More advanced CAFM systems may also be described as integrated workplace management systems. Many larger portfolios may also have a common data environment, or CDE, for asset information, and many buildings will also have a building management system. But as with CAFM, there is a wide range of capability here. I'll cover BMS later when I come to carbon net zero. CAFM are indispensable in the effective day-to-day management of buildings. They provide the means of managing both repairs and keeping on top of safety inspections and scheduled interventions. But using a CAFM system does not necessarily mean that you have solved all your problems. Clearly, data in a CAFM system needs to be stored consistently and kept up to date. But there are also sometimes other issues that are worth looking at. CAFM systems are designed to support day-to-day management and monitoring rather than providing a strategic perspective. Most systems are optimised for facilities managers. Great for them, but not necessarily ideal for asset owners. Not all systems have the ability to hold 3D physical model data well, and of course there's the data ownership consideration that I mentioned earlier. Common data environments are quite different from CAFM systems. They do hold some of the same physical model data, but are typically designed from the outset to encourage collaboration between several stakeholders in managing assets via 3D models. They are therefore often a good basis for the physical twin element of a future digital twin. Asset owners who want to encourage collaboration and want more direct control of their data should consider a common data environment designed for asset management. A CDE is likely to be a good investment if your estate is large and complex, your estate is managed by more than one facilities management contractor, especially if you're planning to re-procure these contracts, or you're planning a major programme of building surveys or capital works. I do recognise the argument that investing in a CDE is an additional expense. I accept this for small portfolios. But in the circumstances I've just described, I would recommend that you think about the value that could be added, including in providing the additional degree of control and data resilience, enabling a more strategic whole life approach across your desired outcomes, creating a consistent single version of the truth across the whole estate, and maintaining a long-term audit trail of all the changes in your buildings to ensure safety compliance. Before I move on to artificial intelligence, a word on data resilience. With so much in the future depending on good data, data resilience is increasingly important. Not only must GDPR and cybersecurity protections be in place, but it's also wise to think about the circumstances in which data could be lost. I've already talked about one of these. Significant data loss at project practical completion is currently commonplace. This is a sector-run goal which we can surely correct. Data can also be lost if it's not backed up. The risk here is greatest in the case of supplier handover or worse, supplier failure. Several years ago, one part of the estate that I was managing suffered a catastrophic data loss. The incumbent FM supplier had lost the contract and my team was working with them to ensure a good data handover. Unfortunately, a few weeks before the planned handover, the supplier's CAFM was corrupted and all the asset data was sadly lost. Perhaps this was a genuine issue, but I always suspected a more spiteful reason for the data loss. Turning now to AI. As my colleague Zoe Webster, one of the UK's leading experts on AI, has said, more and more businesses across the UK economy are increasingly realising the potential that data and analytics could have on their productivity and competitiveness. However, some sectors are much more engaged than others, such as finance and health. I would add to this by observing that there has been less progress to date in the built environment sector. There are therefore significant opportunities for AI in asset management and in maintenance. Again, I would defer to others for a more academic approach, but I like to think about AI as a guessing engine. It guesses what might come next. Perhaps you're thinking a guess is not much use to me. I would challenge that a little. A what comes next guess by itself is not so useful. But if it's based on an understanding of the thousands of times that I've seen this situation before, a guess can be a near perfect prediction. With enough data to learn from, AI can get better and better at these guesses, enabling a guess based on trends to become a reliable prediction. More than good enough to allow decisions to be made. This opens up some big opportunities providing that your data is AI ready. This is not necessarily straightforward. On your journey to the future, it's worth thinking about what you will need to do near the beginning of the journey so that you can employ AI at some future time. I would suggest first, have a solid foundation of base data. Data that meets the single version of the truth criteria that I talked about earlier, starting with solid physical data. Second, ensure that you're collecting dynamic performance data repeatedly over time to create the trend data on which AI can feed. And thirdly, to support delivery of your desired outcomes, ensure that your minimum viable dataset contains the most reliable data with the best trend information over time. Some example opportunities for AI include, firstly, an experience. Building users give their views about the building in which they work in multiple ways over time: requests, complaints, feedback, and surveys. To the human eye, it's a raft of conflicting and often confusing data. But to an AI engine, this is an ideal database from which themes and trends can be readily discerned. Secondly, predictive maintenance. I touched on this earlier, and AI can clearly provide a great vehicle for predicting right-time interventions. And thirdly, lifecycle replacement. In a similar way to predictive maintenance, but on a larger scale. When is the right time to replace a building subsystem, such as an HVAC system? Predictions derived from AI can take into account cost, condition and carbon and help to predict the best time to act. There are also significant opportunities to use data and technology, including AI, in reducing carbon emissions, which makes a good segue into the next section of this keynote on climate adaptation and carbon net zero. Regrettably, climate change is not in the future. It's upon us today, and we know that it will get worse before it gets better. Our climate will be hotter, and weather events will be more frequent and more extreme. The very least we can do is to take action to make our buildings more resilient to the pressing issues of flood and temperature. On flood, the best thing you can do is don't build in the floodplain. If you're already in the Environment Agency's flood risk area, do think about what you can do. Are you happy to retain the asset and potentially face higher insurance premiums in the future? There are some obvious actions you can take to protect against flood, including flood protection at the building perimeter and moving key facilities to an upper floor. For example, when I was leading the UK's largest commercial office programme at HMRC, I insisted that main IT equipment rooms were on the first floor rather than the ground floor, which was normal industry practice at the time. An interesting story about a government building, occupied as many are by several government agencies. It was on the riverbank in an area known to flood, and as such we agreed a plan to surrender the building at the coming lease break and move to a better building closer to the city's transport nodes and outside of the flood risk area. So far so good, but what we didn't know was that one of the occupiers had built their operations room, complete with expensive monitoring and communications equipment, on the ground floor. Unfortunately, the move to a new building did not come soon enough, and when the flood came, the building's local flood protection was quickly overwhelmed, and the operations room was ruined by water. The ground floor is not the best place for expensive IT. Like flood levels, temperatures will also continue to rise. If comfort conditions are to be maintained, which are essential for good experience, buildings will need to be upgraded. Better building insulation and shading are good ideas as they address two issues. Not only do they provide better resilience against higher temperatures, but they also reduce the energy demand for cooling. Air conditioning and cooling systems also need to be considered to ensure that they're capable of dealing with the higher ambient temperatures that will be experienced. Perhaps something to consider at the next life cycle replacement opportunity. As well as taking action to respond to the changes in the climate that are already upon us, I suspect that your desired outcomes will include reducing carbon emissions to limit the further effects of climate change in the future. Not only is this the morally right thing to do, but owners and investors are increasingly requiring it. In the London commercial office market, the rent that can be charged for a low carbon office is up to 10% higher than a building that performs poorly in this respect. The effect is even higher in other cities, for example in Singapore, where the differential is closer to 15%. Since rent drives value, value is similarly inflated by good carbon credentials. We can expect the same differentials to begin to be seen in other property markets. If increasing the value of your asset does not persuade you to take some action on carbon, then the government is keen to have a say. The law currently requires a lettable building to have a minimum energy performance certificate or EPC of at least E for it to be let. In the EU, similar legislation exists and is being tightened in the next few years to a minimum of C. This trend will come in the UK too. If your portfolio includes buildings classified as EPC D or E, you really ought to be acting to future-proof them now. Some of you may say that EPC is not a great measure. I hear people say that it's a hammer to crack a nut, and that a good EPC does not necessarily mean operational energy performance will be any better. I may well even agree with these points, but from the point of view of the law, EPC is the measure, and these excuses will fall into the same category as my dog ate my homework. There are several interventions that can make a difference to carbon emissions and EPC, and they would sit nicely on our journey to carbon net zero. Some are more disruptive to building users than others, and each has a cost and a payback period. What to do next will depend on where you've got to so far in the journey to future-proofing your buildings. Early interventions that are relatively low cost with decent return on investment include things like improving insulation, including by installing better windows. As discussed earlier, this can be a climate adaptation, carbon reduction double whammy. Replacing old-fashioned lamps with modern LED lighting with a typical payback of 1.5 years, installing modern lighting controls with a payback of perhaps 2 years, and where possible, installing solar photovoltaic cells on roofs or at ground level with a payback that might be 6 to 8 years. And often overlooked, changing electricity supply to a tariff based on 100% green energy, potentially a little more expensive, but instant reduction in reportable Scope 2 emissions. When the base data has reached a good enough standard, there are also options to use AI to reduce carbon emissions and costs in operations. AI can be used for predictive ramp up, ramp down of building systems based on trends rather than clunky top and bottom set points, for instance to control temperature and air quality more efficiently. Other more expensive interventions fall into the arena of significant retrofit. These may include things like, firstly, the installation of a modern building management system. A good BMS can prevent the obvious errors such as running heating and cooling at the same time, but also help to operate the asset in the optimum way. Secondly, the removal of fossil fuels from the building by either connecting to district heat systems or the local electrification of heat by replacing gas boilers with heat pumps. Both of these options are expensive and do not have short payback periods, but removing fossil fuels, whilst perhaps not step one, is certainly one of the steps on the journey to net zero. In bringing this section on carbon net zero to a close, I would point out that whilst apparently quite separate from the previous sections on data and digital, that isn't completely the case. Ideally, decisions on carbon net zero interventions, both small and large, will be evidence-based, informed by data, and perhaps even guided by AI. I mentioned at the outset that many of the tasks that need to be done on the journey to the future are interrelated. The links between carbon net zero and better data are just one example of this. I am now coming to the end of what I have to say. I've covered a great deal of ground, and I hope that those starting their journey towards future-proofing their assets will have been able to note down a long to-do list. I now come to perhaps the most difficult collective challenge. How do we build the skills necessary to begin to tick off the earlier steps along the journey and to plan for the later, more difficult steps? The government certainly has a role in building the skills needed. So do universities and schools. But any views that I might have on those subjects are for another day. I want to focus on the built environment sector itself, the people listening to this talk. What can we do now to start building the skills needed without waiting for external help? Growing the right skills at the pace required is a major task. But just like the journey to future-proofing our assets, it must begin somewhere and can begin with small steps. Some things that we could certainly consider include things like recruiting younger people, more graduate entry and apprenticeships, recruiting more engineers and data scientists, improving the diversity of the sector. In my experience, the broadest range of ideas from the broadest backgrounds generally gets the best business results. For our existing workforce, providing education and training in digital and green skills. Although slowly improving, skills in both these areas are currently too low. The The people who work in the sector need and deserve some help in these areas. And looking wider, we can learn from related industries. For example, IT service management is virtually identical to FM, but there is currently, rather surprising to me at least, very little crossover. Without the necessary skills, any early enthusiasm for future-proofing our assets may begin to wane. Taking early actions on skills will help to avoid this, and I believe that it's an essential investment in the future. In concluding, I recognise that there is lots to do to future-proof our buildings. I know that it can seem too much. This keynote has been about starting on a journey towards future-proofing built environment assets. I hope that those of you who are still listening, perhaps there are even one or two, will have been able to reflect along the way on how we might start this journey. I hope that I've provided some actionable advice. We might identify desired outcomes, start small and build to the future, gather the right data starting with a minimum viable data set, build a single version of the truth to enable better, faster decisions, adapt our existing assets to respond to the changing climate, intervene to reduce carbon emissions and move towards a net zero future, and importantly, grow the skills necessary to get going on the journey and hopefully to build up speed as you go. There's an old Chinese proverb that says, "Every journey starts with a single step." I hope that you will take away some of the ideas I've presented here. Put to one side the lure of the strategy of hope and get started on the journey. Even small steps taken early will make a big difference later. I've been Steven Boyd, and I hope that you've enjoyed listening to this keynote.